This is a video of the review questions for the Unit 1 test in Geometry Regents. I am going to start at question 15 and work my way up because most students seem to have done at least 1 to 14 in class. The answer key is also posted on Edline. Just a word of caution, please don't watch the whole video. Go to the problems that you're having trouble with. There's no reason to sit and watch the entire video. That's not productive. So go to the problem that you're having trouble with and then watch the video. All right, so number 15 says in a triangle, the measure of the second angle is 6 times the first. So I'm going to draw a triangle. And I'm going to label this triangle, the vertices A, B, and C. So in a triangle, the measure of the second angle is 6 times the first. So I'll call B the second angle, and I'll say, well, that's 6 times the first. So I'm giving a name to the first angle, otherwise known as x. That thing that comes at the end of the sentence is your variable. So x, the angle A, I'm going to call that my first angle is x. And it says the measure of the third angle is 20 more than half the second angle. Well, half the second angle is 6x. Half of 6x is 3x. And I need 20 more. So that would be 3x plus 20. Now that I have this all translated, I can go ahead and try to figure out the value of x, which then will help me figure out what type of triangle this is. So we will now add up. We have all 3 interior angles of the triangle. So all 3 interior angles of a triangle add up to 180. Combining like terms, we get 10x plus 20 equals 180. I'll subtract 20 on both sides. I get 10x equals 160 divided by 10, and x is 16. I'm being asked to determine what type of triangle this is, so I need to go back with this x value and plug in or evaluate each of the angles measurements. So this guy, the angle A here, is 16. Angle B is 6 times 16, or 96. And angle C is 3 times 16 plus 20, which is 48 plus 20, which is 68. So now I know the angles of the triangle are 16, 96, and 68. And therefore, this triangle is obtuse because I have one angle in the triangle that's greater than 90 degrees. The other 2 angles, and we've discussed this, must be acute angles in an obtuse triangle. Otherwise, the sum of the angles would be greater than 180 degrees. So it's not these acute angles that make the triangle acute. It's the one obtuse one that forces the triangle to be obtuse. All right, so number 16. Number 16 says, are there 2 sides of triangle ABC that are congruent? If so, which ones? Show your work, justify your answer. Well, they gave us information about the 2 interior angles and the remote exterior angle. And so we can use the exterior angle theorem to set up an equation. So I'll say the 2 remote interior angles add up to the exterior angle. That's what the exterior angle theorem says. Now I have a quadratic equation, so I will move all the terms to the quadratic side. So subtracting 8x and 20. So we will get 0 equals x squared minus 8x minus 20. And now to solve this, we must factor. So I'm looking for 2 numbers that add up to -8 and 2 numbers that multiply to -20, since we're doing I am factoring. And the pair of numbers that satisfies this is -10 and 2. So now I get x minus 10 times x plus 2 is equal to 0. Setting each factor equal to 0. I get x is 10 and x is -2. But if x were -2, then angle B would be -16. So I have to reject this and keep my x as 10. So now I'm going to go to the picture and plug in x as 10. So 8 times 10, this angle up here is 80. X squared is 10 squared, which is 100. And I'm being asked to say whether or not there are two congruent sides of triangle ABC. So essentially, another way to word this is I'm asking, is triangle ABC isosceles? Okay. And so I'm going to get this other missing angle, the angle ACB right here, which, if I do 180 minus 100, because these two angles, the 3 swooshed and the 2 swooshed in red, lie on a line together, they're a linear pair, I'll do 180 minus 100, which is 80. So this is 80, which is congruent to angle B. So opposite the congruent angles in the triangle, you will find the congruent sides. So I would write that AB is congruent to AC because triangle ABC is isosceles and AB and AC are opposite the base angles of triangle ABC. Whenever the question says to justify your answer, you need to write a sentence. All right, number 17, in the diagram below, they want us to find the measure of angle BFD. So you kind of have to go here and look at what you have and look and see what you can get real quick. So, for example, this angle is 154 degrees. I can get the next door neighbor by subtracting from 180. 180 minus 154 is 26. Now I have triangle BFC. And I have two angles of that triangle. So I can say, well, 26 plus 16 is 42. And since the angles of a triangle add up to 180 degrees, I have 180 minus 42, which is 138. And that 138 can go right here. Then I can say, well, I have this 138 degree angle. And that's supplementary to this angle. So we can do the same thing we kind of did at vertex B. We can do 180 minus 138, and that gives us 42. There's a 42. Now I really can't do anything else until I realize, oh, I have this angle over here, the 158, and I can get this guy right here by subtracting from 180 again. So 180 minus 158 is 22. Now I have triangle CFD, where I can find angle CFD by adding up the 42 and the 22, which is 64. 180 minus 64 is 116. So this angle is 116. I'm being asked to find angle BFD, but now we have all little piece angles here. I can find angle BFD by adding up the 16 and the 116. It's this angle here. So measure of angle BFD equals 16 plus 116, which is 132. Number 18 says the vertex angle of an isosceles triangle is 12 more than the square of one of its base angles. Find all of the angles in the triangle. So I have my isosceles triangle. The vertex angle is 12 more than the square of one of the base angles. So I'll draw this. My vertex angle is the odd man out. And the vertex angle is 12 more than the square of one of the bases. That's how I can translate it. And the base angles, therefore, are represented by x, or their measures are represented by x. So I have the three angles of a triangle labeled. So I can add up those three angles and sum them to 180 degrees. Cleaning up this left-hand side, x plus x is 2x, and I would like to put this polynomial in descending order. So meaning the x squared goes first, the x term goes next, and the number goes last. Again, we have our x squared term in this. It's quadratic, so I need to move everything over to the quadratic side. So we'll subtract the 180. And now we have x squared plus 2x minus 168 is equal to 0. And we would like to factor this. So I am looking for two numbers that add up to 2 and two numbers that multiply to negative 168. And the magic pair of numbers is 14 and negative 12. And so those are our factors. Since those are the factors, I solve the quadratic by setting each factor equal to 0 and solve the little baby equations. And so x is negative 14, or perhaps x is 12. Negative 14 will result in negative angle, so I reject this, keep this guy. And so x is 12. So they're looking for all the angles of the triangle. So the base angles are each 12. So the base angles are 12 apiece. And the vertex angle is 12 squared plus 12, which is 156. Final answer. Number 19 says in triangle ABC, the measure of angle B is 110. And then it says also let me label triangle ABC. Angle B is 110, and the measure of an exterior angle at C is the square of the measure of angle A. So this is interesting. I have to extend past C, and the measure of the exterior angle is the square of angle A. So if I called angle A's measure x, so I'll put that x in there, the exterior angle at C is x squared. And it says find the measure of the interior angle at C. So I will set up an equation. The two remote interior angles, the x and the 110, have to add up to x squared. And again, we'll move all the terms that are not quadratic over to the quadratic side. So we get 0 equals x squared minus x minus 110. I would like to use IM to factor this. I am looking for two numbers that add up to now negative 1 and multiply to negative 110. And the pair of numbers that does this is negative 11 and 10. So we get 0 equals x minus 11 times x plus 10. Get x minus 11 equals 0. X plus 10 equals 0. So x is 11 or x is negative 10. I'll reject negative 10 because angle A can't be a negative. And now I have my x value. So the question asks me for the interior angle at C. So I'm looking for the angle I just swooshed off. So I will plug in into the exterior angle, which is 11 squared, which is 121. So the interior angle at C is equal to 180 minus 121 for a final answer of 59. Number 20 says the measure of a base angle of an isosceles triangle is 9 less than 4 times the vertex angle. So my base angle measures 9 less than 4 times the vertex. So the vertex angle is x. And the base angle measures 9 less than 4 times the vertex angle. So it would translate to 4x minus 9. And since it's an isosceles triangle, the base angles are equal. And now it says find the measure of each angle of the triangle. So we can add up the 3 angles of the triangle. And sum them to 180. Combining like terms, we would get 9x minus 18 equals 180. Add 18 over. So we get 9x is 198. Divided by 9. X is 22. So I know the vertex angle is 22. And the base angle, so the vertex angle is 22. The base angles are each 4 times 22 minus 9, which is 79. So the vertex is 22. The base angles are each 79. Number 21 was harder. So I'll show you a slightly different way of doing it than I did it in the key. It says find the values of x and y in the triangle below. Well, if I look at this triangle, these are my 3 interior angles. And I know those interior angles have to add up to 180 degrees. something interesting happens with this. If I look at this, if I look at the left-hand side, I have a positive y and a negative y. And those drop out, which is great because now I only have one variable left. So these cancel, and I have 5x plus 4x left, which is 9x. I divide by 9. X is 20. So now if x is 20, I can find y in a couple of different ways. One way I can find y is to notice that this angle, 4x minus y, is equal to 130. Is equal to 50, because 180 minus 130 is 50. So 4x minus y is 50. And we just said x was 20, so 4 times 20 minus y is equal to 50. 80 minus y is equal to 50. And you can clearly see 80 minus 30 is 50, so y is 30. 22 says, in triangle ABC, D is the midpoint of side AC, and measure of angle A is congruent to the measure of angle C. Or sorry, equal to the measure of angle C. So we have triangle ABC. D is the midpoint. So if D is the midpoint, that means AD and DC are congruent. That's important. Then they told us the measure of angle A was congruent to the measure of angle C. So I have a swoosh here, a swoosh there. And then now I have an isosceles triangle. Triangle ABC is isosceles. So I know across from angle A is one equal side and across from angle C is the other. Now notice I used 2 dashes on them because I already used 1 to mark off AD congruent to DC. So it says if AD is 2x minus 5, 2x plus 5, and it says some other stuff. But if AD is 2x plus 5 and D is the midpoint of AC, then DC is also 2x plus 5. That's why sometimes it's easier to take one piece of information and just see what you can make. Then AB is 3x. So if AB is 3x, and we just said AB and BC were congruent, then BC is also 3x. Now we know the perimeter of the triangle is 50. That means if I add up all the sides of the triangle, I would get 50. And I want to find the length of DC. So now I'm obligated to kind of add up all the sides of the triangle. So I have my 3x, and then the long side AC here is 4x plus 10. And that's equal to the perimeter of 50. So 3x plus 4x is 10x. Subtract 10 on both sides. 10x equals 40 divided by 10. X is 4. If x is 4, I'm looking for the length of DC. Well, DC is 2x plus 5. And so DC is 2 times 4 plus 5, which is 13. And that's it. Number 23 says, in the diagram below, CD bisects AB at E. So CD is the knife that is cutting AB into 2 equal pieces. Bisects means to cut into 2 equal pieces. So AB is being cut into 2 equal pieces, AE and EB. AB, from A to B, is 4x minus 6. AE is 3x minus 10. But I want to stop reading there and notice AE and EB are equal. So I can label EB also with 3x minus 10. And the measure of angle D is congruent to the measure of angle B. So I'm also going to notice there that triangle EDB is isosceles, and opposite the congruent angles, I find the congruent sides. So 3x, the EB rather, is marked off already, and I would also have to mark off side ED. So ED, since it's equal to EB, is also 3x minus 10. Do you see how I made conclusions there as we went along? Now it says that the perimeter of triangle DEB is 30. They want you to find DB. Well, one big problem is here is we don't have x. So we need to use this long line segment to set up an equation. This guy right here. And my equation is going to be, well, 3x minus 10 plus the other 3x minus 10 equals the whole thing, 4x minus 6. So I get 6x minus 20 equals 4x minus 6. Add 20 on both sides. Actually, no, sorry, I won't do that first. Subtract 4x on both sides. 2x minus 20 equals negative 6. Add 20 on both sides. 2x is 14 divided by 2. X is 7. So now x is 7. So now I want to find, well, I can find lots of things now. I can say that this side is 3 times 7 minus 10, which is 11. Which also makes DE 11, since those two sides are equal. And I know the perimeter of triangle DEB is 30. So this triangle has a perimeter of 30. And I've already counted for 11 and 11 of those 30. So I can go 11 plus 11 is 22. And so DB would be 30, the perimeter, minus 22, which is 8. So 8 is the final answer. All right, 24 says in the diagram below, it says if BE bisects angle ABC. So I'm going to draw this a little differently. I'm going to draw just BE here. This is E. This is B. It's bisecting angle ABC. So what I know by that is bisector cuts the angle into two equal pieces. So I can say ABE, this angle, swoosh, is equal to angle EBC. So from there, I can say angle ABE is congruent to angle CBE. That's all coming from this part. And I drew it separately because sometimes when you have that extra line segment that we're going to talk about in a minute, it can be confusing. Now, BD is bisecting AC, this guy. So now AC is getting cut into two equal pieces, namely AD and DC. So we know AD is congruent to DC. And now it says we have to look at the choices. So choice 1 says, Roman numeral 1 says, ABE is congruent to angle CBE. I agree with that, based on this picture. 2 says angle ABD is congruent to angle CBD. Well, that's not necessarily true because I didn't say that DB was bisecting angle ABC. And then thirdly, AE and EC is not true because BE is not bisecting AC. So 1 only is the answer. 25 says, in triangle ABC, the measure of an exterior angle at E is 100. Sorry, at B is 100. So here's my ABC. Now, if you draw it like this, the exterior angle at B is I can pick either side to extend. I extend like that. And the exterior angle at B is 100. Then it says the measure of angle A is 4 times as larger than the measure of angle C. So I can say A is the 4x and C is the x. So now I can set up an equation. I have my two interior angles adding up to my exterior angle. So 4x plus x is 100. 5x is 100. Divide by 5. X is 20. And angle C is x. So the measure of angle C is 20. Number 26 is a fantastic question. It says in triangle ABC, if an exterior angle drawn at vertex C measures 45 degrees, then angle B. I'm going to try to draw a scale picture of this. Here's my exterior angle at C. And here is the triangle. So this guy is 45 degrees. Now, if you look at the other angles, angles A and B, you notice they have to be acute. Because we know that angle I want to write A plus B has to be 45. So that means A itself has to be less than 45, and B itself has to be less than 45. If angle B is less than 45, it has to be acute. That's the definition of an acute angle. I really like that question. It's a good thinking question. It's a good conceptual question. 27 says, in isosceles right triangle ABC, so two words, isosceles and right. Here it is. I have my right angle, I have my two sides are congruent, and right off the bat, I have my two angles that are congruent. I'm not even going to read the question, besides the fact that angle C is the right angle. So angle C is the right angle, and say here's A and B. Right off the bat, I can get the other angles of the triangle, because I can say, well, this is 90. 180 minus 90 is 90. And 90 divided by 2, because the two angles left over are equal, are each 45. And it says find the measure of the exterior angle at A. So I will extend one side, and now I will find the exterior angle at A, which is just 180, the straight line, minus the angle that we already have, which is 135 for our final answer. Number 28 says, in triangle ABC, the measure of an exterior angle at B is 5 more than twice the measure of angle C. So again, we can draw our triangle. Here's ABC. The measure of the exterior angle at B, so I'm extending B, one of the line segments at B, is 5 more than twice the measure of angle C. So this is X, angle C is X, and the exterior angle B is 5 more than twice that. And then they told us measure of angle C is 65. Well, that's kind of unusual. They kind of gave away the measure of angle C. So all we have to do is plug in to know that X is 65. So 2 times 65 plus 5 will actually get us 135 for the exterior angle at B. But they're asking for the measure of angle A. So this guy here is 135, and there's a couple of ways to get A. You could go back into the triangle like this, subtract from 180 to get this angle. So 180 minus 135 is 45. And so now I have a 45 and a 65 in the triangle. So I can add those guys up, which gives me 110, and subtract from 180, which gives me 70 degrees. That's one way to get angle A. The other way is to use the exterior angle theorem backwards. I have 135 as the exterior angle, subtract the one interior angle, and if I subtracted 135 and 65, I get 70. Number 29 says, two angles of a triangle have measures of 55 and 65. So I'll draw those in. 55, 65. It says, which could not be a measure of an exterior angle? Well, the triangle really has 1, 2, 3 exterior angles that I could look at. So this first exterior angle on the left would be 180 minus 55, which is 125. The second, so I'm doing 180 minus 55. Oops, sorry. 180 minus 55 to get 25. Then over here, I can do the same thing. I can do 180 minus 65 to get the exterior angle. 180 minus 65 is 115. Then I can look at these two interiors, and I could go get this interior and then get the exterior, or I can use the exterior angle theorem and just add them up. So 55 plus 65 is 120, and that's this other exterior angle out here. So my exteriors are 115, 120, and 125, leaving 130 out in the dust. And that's not one of the measures of the exterior angles. Number 30 says, the measure of an exterior angle of a triangle is 120. So I'll draw a triangle with an exterior angle of 120. And the measure of one interior angle is 50. Well, it can't be this angle, because to get this angle, the adjacent one to the 120, to the exterior angle, I could do 180 minus 120 is 60. So that's 60. So one of the other angles must be 50. So I'll put it there. It says find the number of degrees in the measure of the largest angle of the triangle. Well, I have my 50 and 60 inside the triangle now, which is 110, and 180 minus 110, which is 70. That's the missing angle of the triangle, and that happens to be the largest angle of the triangle, so that's the answer. 31 says, in the accompanying diagram of triangle AEB, EB is extended through to R and K, and angle 3 and angle 4 are equal, and they're both 135. So now I can get angles 1 and 2, which I hope you see are equal. I can just subtract from 180 to get both of them. So those are each 45. And then the question is asking what type of triangle is this? So I need to get the missing angle. So I'll add up the two angles that I have and subtract from 180, which is 90. And so now I know the triangle must be right because there's a right angle, 90 degrees, and isosceles because there are two equal angles. Number 32 is tricky. Number 32 says, in the accompanying diagram of triangle ABC, AB is congruent to AC. So you know what I'm going to do with this? I'm going to draw the skinny triangle without... I need to draw it more skinnier than that. Let's see if I can. Nope. Sorry. I'm going to draw the skinny triangle without D involved, just so we could see something, and that's a good strategy sometimes. If I have triangle ABC, they told us AB is congruent to AC, so what that means is this is an isosceles triangle, and opposite the congruent sides, I will find the congruent angles. Then DB and DC are angle bisectors. So DB is bisecting angle ABC into two equal pieces. And that same thing is happening over here. But notice, angle ABC and angle ACB were equal. So their halves will be equals also. So all four of those angles are actually equal. And angle BAC is 20. So if angle BAC is 20, I can find angle ABC and I can find angle ACB. So 180 minus 20 is 160. Divide what's left over by 2, and I'll get 80 for angles B and C. If angles I should say ABC and ACB, if each of these angles, the big guy is 80, and I want to zoom in here, so just give me a brief moment here. Nope, sorry. What we just figured out is that angle ABC is 80. If that's 80, this angle here is 80 degrees. Each of the little guys, each little pieces are 40 apiece. Okay? And the same thing happening over here. Okay? I'll zoom out again now that we can see that, hopefully. So, it says find the measure of angle BDC. So now I have another triangle, BDC, where these base angles are 40 and 40. So I can add those guys up. That's 80. And subtract from 180 to get the missing angle, which is 100. So a measure of angle BDC is 100. That's a trickier problem for sure. Number 33 says, in the accompanying diagram, BA is congruent to BC. And the measure of angle X is 117. Find the measure of angle Y. Well, I have an isosceles triangle in here, so I know these two angles are equal, the ones opposite the congruent sides. And then I can get this angle right here by doing 180 minus 117, which is 63. So that makes this angle 63. And angle Y is vertical to it, so the measure of angle Y is also 63 degrees since vertical angles are equal. Number 34. In the accompanying diagram, it says BD bisects acute angle ABC. So since BD is bisecting ABC, I can go swoosh and swoosh, which means those two angles are equal. And then it says AD is parallel to BC. These guys are parallel lines. And so if we know their lines are parallel, we know the alternate interior angles formed by the transversal are parallel if we look for the Z. Here's my Z. The elbow angles of the Z, well, one of them is marked off right here, and the other one's up here. So I can swoosh all three of those angles with one swoosh. Now it's asking me what kind of triangle must triangle ADB be? Well, I have two congruent angles, so the triangle is isosceles. Number 35 says, in the accompanying diagram of triangle ABC, I have a straight line BDC. DE is perpendicular to AEC, and a bunch of other angle measurements. And it says, what is the measurement of angle DAC? Well, I'm going to look for what I can. And I certainly have two angle measurements here, and I'd like to get the third. So if you notice, all three of these angles form a straight line together. So I will add up the 70 and 40 I already know, which is 110. Subtract from 180 for the straight line, and that is 70 as well. So this missing angle is 70. Now I know I have a 90-degree angle here, and I'm looking for angle DAC, which is up here. Now it's a pretty easy question. I just can use triangle DAE to get it. So I can go 90 plus 70 is 160, and 180 minus 160 is 20. So the measure of angle BAC is 20. Number 36. In the accompanying figure, it says line EGF intersects AB and CD, and AG is drawn, and we have parallel lines again. So AB and CD are parallel. And they gave us a bunch of angle measurements. So again, I want to find angle EGA, but if you look, it's tough. I have a triangle AGF here, and I have 2x and 3x in the triangle. So what I can do is use the parallel lines here and look for the Z. And the Z is formed right here. And the elbows of the Z, one elbow angle is an X, the other elbow angle is right here, and those are the alternate interior angles. And because we have the parallel lines, we know they're equal. So that guy gets an X. And now I have the triangle with all three of its angles labeled. So they're all in the interior. So I can add those angle measurements up to get 180 degrees. This is 6x equals 180 degrees. Divided by 6. X is 30. They're asking for angle EGA, which is right here. But I can get its next door neighbor, its linear pair partner there, by plugging in the 30 into the 3x. So I have 3 times 30 is 90. And since those two angles, the one I want and the current one I'm working with, lie in a straight line together, I can subtract from 180. 180 minus 90 is 90. And that is the measure of angle EGA, is 90. Perfect. 37. 37 says in the accompanying diagram, BD is perpendicular to line ABC. So what that means is BD forms a right angle here and also a right angle here. And BE is perpendicular to BF. So BE and BF also form a right angle. And then it says this angle FBC is 20. They want us to find another angle. So I'm going to find other angles in this picture. So for example, I can use this first big right angle to go, well, I have 20 accounted for. 90 minus 20 is 70. So this is 70 right here. Then I can say I have this other big right angle of which 70 of it is accounted for. Hope we all see that 70 out of the 90 is accounted for. So this other angle I can get by doing 90 minus 70, which is 20. And that happens to be angle EBD, which is what they wanted. 20 degrees. Number 38 is a lovely question. It says in the accompanying diagram, line ABCD is a straight line, and angle E in triangle BEC is a right angle. It says, what does A plus D equal? Well, a couple ways to answer this. Angle A is an exterior angle, and so we know the remote interiors add up to it. So A is equal to 90 plus C. Similarly, D is an exterior angle, and now the remote interiors are 90 and B, the ones far away from it. So D is equal to 90 plus B. I want A plus D. So I know A plus D, if I kind of add up the left-hand side of the equations, equals the sum of all these things. So 90 plus 90 is 180, plus B plus C. Well, A plus D, they claim I can get a number for this. Well, B and C, if I think about it, B plus C, I can get that because I know that they're in a triangle at 90 degrees. So 180 minus 90 is 90, and B plus C have to add up to 90 degrees. So B plus C is 90. And 180 plus 90 is 270. That's a great question. Tough, though. Tough question, but a very good one. Number 39 says, in the accompanying diagram, L is parallel to M. T and S are intersecting transversals. The measure of angle 1 is 130 degrees. The measure of angle 2 is 60. I'm actually going to zoom in here, I think. Because there's a triangle in here that's pretty tiny. Here we go. The measure of angle 2 is 60. My pen's going to be really fat here, but that's okay. And I want to find the measure of angle 3. Well, I have my two parallel lines, which is huge, as you would imagine. I have my L and my M. Two parallel lines. And so this angle is 130, angle 1. This angle right here is 180 minus 130, which is 50. Sorry, I was just playing around with the pen, seeing if anything would work better. So this angle here is 50. And again, I can form my Z for the parallel lines. So I can get a highlighter here. Here's my Z, or 1Z. And I have an elbow of 50, which makes this elbow 50 up here. Angle 2 is 60, which makes that vertical with this angle that I just marked off is 60. And now I have the three angles, well, 2 out of the 3 angles of this triangle. So 60 plus 50 is 110. 180 minus 110 is 70, and that's the measure of angle 3. Final answer. Another really good conceptual question. If you really understand what's going on, you'll understand these questions. All right, number 40 says, in the accompanying diagram, line CAB is parallel to the line DOG. AO is a transversal. CAO is 2x, and the measure of angle DOA is 3x plus 40. Find the measure of angle GOA. So we have our two lines cut by a transversal, parallel lines rather, and we have this guy being an acute angle and this guy being obtuse. And we said in this situation, those angles are supplementary. This kind of goes back to the first quiz. So 2x plus 3x is 5x, plus 40 equals 180. Subtract 40 on both sides. 5x is 140. Divide by 5. X is 28. If x is 28, they want me to find angle GOA. So you could do this one of two ways. You could see that angle GOA, which is right here, is congruent to the 2x because they're alternate interior angles. So the measure of angle GOA is 2 times 28, which is 56. You could also plug into angle DOA and subtract from 180. That's another way to do it. Number 41, in the accompanying diagram, AB and CD intersect at E. AC is parallel to DB. So we have AC and DB parallel lines. And they gave us two angle measurements. Here, I can look for the Z to find my alternate interior angles, and there are actually two Z's that get formed. One Z is here, like this. And so I have my elbows. Here's one elbow, and here's the other. So this is 41. And I can kind of look at this triangle DEB, and find the missing angle. So I can find this guy right here. So 56 plus 41 is 97. 180 minus 97 is 83. So this angle is 83. They wanted me to find angle AEC, which is vertical from the 83. So the measure of angle AEC is also 83. Another way you could have done this is to look at the other Z going the other way, using the same parallel lines but a different Z. So that would make this angle 56. And then basically do the same calculations, and you'll get the 83 degrees. Either way is great. I don't think one's necessarily better than the other. Number 42 says, in the accompanying diagram, we have AFB parallel to CDE. So those lines are parallel. And FD is bisecting angle CFB. So if FD is bisecting angle CFB, X and W are congruent. That's what it means to bisect an angle. Now we also know that we have two parallel lines cut by a transversal. So I will look for the Z. And in the elbow, this time the Z goes backwards. Let me highlight that in a different color. The Z kind of goes backwards this time. So I get my elbow angles at X, my alternate interior angles in Z. So, and I will put one swoosh because X already had one swoosh, and anything that's equal to it gets one swoosh. So now it says which statement is true. Well, W and Z each have one swoosh. They are equal to each other. Since W and X were equal and X and Z are equal, W and Z have to be equal. So for example, if X was 20, we know W was 20. And since X is 20, Z is 20. And so W and Z both have to be 20. That's something actually called the transitive property that we'll use later on in proofs. Number 43 says, in the accompanying diagram, ABC is parallel to DE. So we have two parallel lines here. FDE is 25, and the measure of angle DFE is 130. They want us to find angle ABE. Well, first things first, I have a nice little triangle down here with two of the angle measurements in there. So I can go 130 plus 25 is 155. Subtract from 180, and we get 25. Then I can notice a few things. There's a couple of ways to go here from here. One thing I could notice is that the 130 is supplementary to this angle here. So I can find that by subtracting it from 180. I can do 180 minus 130, which is 50. This angle is 50. This angle is 90, which can help me find out another angle, namely this angle down here. So I can do 50 plus 90, which is 140, 180 minus 140, which is 40. So this is 40. And now, there's a couple of routes you could go here. I'm asked to find ABE. We haven't used the parallel lines yet, so I'm going to look for a Z here. And here's one Z that you can find. Ooh, that is bright. I don't like that color. Let me undo that. And let me use a different color. Even though that color is really a nice color, it's not the greatest for this. So I could find my alternate interior angles by looking at the elbows. This guy's 25, and this guy's 25. Now I'm being asked to find angle ABE. ABE is here. I have to get that X. So how do I get the X? Well, one way to do it is to realize X, 90, and 25 are on a line together. So X plus 90 plus 25 is 180. X plus 115 is 180. Subtract 115. And X is 65. So X is 65. But the measure of angle ABE is the 65 plus the 90. It's the wide angle, which is 155. Last but not least, number 44. In the accompanying diagram, it says EBD is parallel to ACF. BC bisects angle ABD. So angle ABD is being bisected here. Swoosh and swoosh. EBA is 40. Find the measure of angle BCF. So a couple of things you can do here. I know these three angles, the 40 and the two equal guys, add up to 180. So I could say 40 plus, well, I could do this a couple of ways. I could subtract 40 from 180. Let me not use variables for this because it's pretty easy. And divide by 2 since each of those angles are equal. So that's 70. So each of these angles are 70 degrees. And now BCF, well, the two lines, the top and the bottom lines are parallel. So yet again, we can look for the Z. Here's a Z. And my elbow angles are 70 apiece. And now BCF is supplementary to the 70 degrees. So I could say 180 minus 70 gives me 110 for BCF. And that's it. Good luck on Monday's test.